Today our topic will be over comparing and ordering integers. Again, integers are a whole number and its opposite. For example, 7, 12, 15, positive 9, positive 12. Those are positive integers. The opposite would be the equal distance from 0, so it'll be negative 12, negative 7, negative 3, negative 2. So let's look at our example today. Mr. Joe's fifth period has a currency fascination. For example, Han found $8 in the hallway. Billy lost $8 during lunch. Alexander spent $10. Someone borrowed $11 from Anthony. Hong withdrew $3 from his savings account for lunch. Esmeralda won $6 from her brother. Savoy had to pay his brother $13. Emmanuel earned $7 from the book contest. List the students from richest to poorest. As I can tell, all of these numbers are what type of numbers? Integers. Integers. Positive and negative whole numbers. So I'm personally going to draw a number line to help me. You don't have to, but I will draw a number line because I need a visual representation. 0, neither poor nor rich. Let's do the positive side. Positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7, positive 8, positive 9, positive 10, positive 11. These students will have money. It's funny how as I keep listing these integers, it's getting greater. Interesting, greater. Let's go on the other side. We have negative 1, negative 2, negative 3, negative 4. Remember, negative 4 is the opposite of 4. 4 units from 0. Negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13. So what's the opposite of negative 13? How many units from 0 is negative 13? 13 units away, so it'd be on the other side. 13 is the opposite. So let's start with first person. Han found $8. So Han will go right here. Han, positive 8. Billy lost $8. That's the complete opposite of Han. Oh, so Han found his $8. So Billy lost $8. Alexander spent $10. So he'll be negative. I call him Alex. Someone borrowed $11 from Anthony. So Anthony does not have this anymore. So Anthony will be right here. Hong withdrew $3 from his saving account for lunch. So he took it away from himself. So Hong. Esmeralda won $6 from her brother. Won. So Esmeralda will be right here, because she has more money. Savoy had to pay his brother $13. So that means Savoy must be down here at the end of this number line. But number line goes on forever. Emmanuel earned $7 from the book contest. So Emmanuel goes right between Han and Esmeralda. And that's it. So list the students from richest to poorest. Hey, it's already. That's why I drew a number line. Han is the richest and Savoy is the poorest. So, as I can tell, the greater numbers are to the right of 0. Wait. Well, that's for positive. But the closer to 0 for negative is greater. From what I can tell, it looks like the least numbers are on the left side. So are we trying to say that this is already from least to greatest? A number line goes from least to greatest, or opposite, greatest to least. So greater numbers are always to the right of a number line. Least numbers are always to the left. That's my generalization for today. So, all right, so let's go there. So from here, numbers are arranged in order from least to greatest on a number line. Numbers get bigger as you keep on going to the right, while numbers keep getting smaller as you keep going to the left. So any number is greater than all the numbers to its left on the number line, or opposite. On any number down here is always less than all the numbers to its right. So again, what are integers? Integers are whole numbers and its opposite. No, no, no. These are all whole numbers to me. Whole numbers. Whole numbers. No, and no. So these are all whole numbers. These are all decimals and fraction, which are not whole numbers. So on this number line, let's do it again. So we know positive numbers here. 0, positive 1, positive 2, positive 3, positive 4, positive 5 right here. So we have negative 1, negative 2, negative 3, negative 4, and negative 5. What happens if I ask you to find a number between 2 and 3 right here? That would be either 2.5 or 2.5. Is that an integer? No. Integers have to be whole numbers. So what if I ask you, is this an integer? You'll say no. Is that a whole number? No. Or is opposite? No. That's negative 4.5 or negative 4.5. You can even say negative 4.50, which is the same thing as negative $4.50. So let's go to the next screen. Looking at the number line, can you tell me which inequality symbol we'll use? Less than or greater than? Let's say 5 was positive. So let's look at it again. 5 is greater than negative 1. Remember, to the right of a number line. So read this one. Yes. Negative 3 or negative 5. Let's see. On the number line, as I picture it, negative 5 would be more here, negative 3 here. So negative 3 is greater than negative 5. Let's make sure. Here's negative 3. Here is negative 5. Negative 3 is closer to 0 or to the right, so it's greater than negative 5. Let's go to this one. Which one's greater, 0 or negative 2? Who is to the right? 0 is. So 0 is greater than negative 2. And let's go back. 0 is to the right of negative 2. Next one, let's try our last one. Negative 4 and negative 2. Negative 4 is more here. Negative 2 is here. I'm visualizing it. So I say negative 2. Negative 4 is less than negative 2. Could you also say negative 2 is greater than negative 4? If I rewrote it like this way, you can. Both of them mean equivalently. So negative 4 is less than negative 2, or negative 2 is greater than negative 4. Put these integers from least to greatest. You can plot them if that's easy for you. So I know negative 4 is here, positive 6 is here, negative 2 is here, positive 1 is here, and 0. So put these from, oh, I'm sorry, let's see. The director said put them from greatest to least. So greatest is positive 6, or just 6, positive 1, or just 1, 0, negative 2, negative 4. Let's put a comma. Let me erase this. And let's try one more example. Ooh, let's try D. Negative 22. If I think about it on a number line, it is way to the left. Negative 36. Is that going to be even farther away from 0? I think so. Negative 1 is right here, and 0. So put them from greatest to least. 0 is the greatest, then negative 1, then negative 22, and then negative 36. The slide is up. Yay! Wait, yep, correct. Slide is up. Yay, it is correct. And let's try our last example. Put these 5 integers, whole numbers in opposite, from least to greatest. If I'm thinking of a number line, who would be farthest to the left? I say negative 24. Then negative 20. Then negative 18, negative 4, and 4 is positive, so that would be. Let's see, check it. We got 5 checks. We got it correct. So what can you tell me? So what did we learn today? In a number line, it goes from least to greatest. So least numbers are to the left of a number line. Greatest number are to the right of a number line. That is the study of putting integers, comparing and ordering integers.